Hello, boys and girls, and welcome to today's math lesson. For today's math lesson, we're going to be going over word problems again. So our I can statement is, I can represent and solve addition and subtraction problems within 20 with unknowns by using objects, drawings, and equations with a symbol for the unknown number to represent the problem. So that is our I can statement. But before we get started, go ahead and get out a notebook and a pencil, and we're going to do some math review. Okay, so you talked about missing add-ins last week with Mrs. Zalaki. We're going to be doing a couple missing add-ins practice problems. So I want you to write this equation at the top of your paper. 5 plus unknown equals 8. Now I know Mrs. Zalaki taught you a couple different strategies to solve this one. I'm going to go ahead and I'm going to use pictures to solve this equation. Okay, so I'm looking for this missing number, this missing add-end, okay? So if, just like you had done in Big Ideas, remember, there was your little chart, and then this was the total number, right? So the total number that we know, the sum, everything all together is 8, right? That's the biggest number, that's 8. Well, we know a part, but we don't know the other part. We don't know the part that we're missing. So we know that one part is 5. 1, 2, 3, 4, 5. But I want to know how many circles I would need to get to 8. So if I'm counting on, okay, so I want to see what I get to 8. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay, now 8 isn't my answer. I'm looking at how many I drew in this spot right here. So in this spot, I drew 3 circles, right? And in this spot, there were 5 circles. So my unknown number, my missing add-end, was the number 3. Okay, so 5 plus 3 equals 8. That's how I figured out that missing add-end for that word problem. All right, let's go ahead and let's practice this one. This is the missing number in a subtraction problem. Now to solve this one, so this is 10 minus unknown equals 7. To solve this equation, I'm going to go ahead and I'm going to use an open number line. And the reason I'm going to use an open number line, and this is just my personal preference and what I tend to see in students, is that an open number line is easier when that second number is missing for addition and subtraction. So it's just kind of a personal preference. All right, so I'm going to go ahead and draw out my number line. Okay, and then when you're in subtraction, remember you're counting backwards. You're not counting onwards. So where we start with our number is we start here, okay? So we're going to start with our number all the way over here on the right side. Now, don't forget, you should be doing this in your notebook with me. Then remember, and I've talked about this before in the past, okay? This is the number you start with, right? This is 10. This is the number I start with. These are the hops you do. And this is what you hop to, so where you end up, okay? So if you need to make that little kind of picture underneath your equation, that's more than okay. So I don't know how many hops it takes to get to 7. So I want to get to 7. So I'm going to go ahead and start hopping backwards, okay? 1 minus 10 is 9, not at 7 yet. 1 minus 9 is 8, not at 7 yet. 1 minus 8 is 7. Now, a lot of kids, they want to put 7 there, but that's not what I was looking for. Remember, I'm looking for the hops I did. So I did 1, 2, 3 hops. So I did 3 hops. So 10 minus 3 equals 7. So that's how I solved that missing number problem. So what we're going to be going over today is we are going to be going over solving equations and solving word problems with that change unknown. So the change is that second number, and we're only going to focus on addition today. So if you could go ahead and get out your Volume 1 Big Ideas Math Workbook and turn to page 45. Okay, so this is Chapter 1, Lesson 8, and you'll see the top of the page says solve add to problems with change unknown. So if you're looking at this picture, okay, and this says use counters to model the story. 5 people are on a subway. Some more people get on at the subway stop. Now there are 8 people on the subway. How many people got on the subway stop? So how I would do this is you see that there are 5 people on the subway, right? There's 5 people. Here's 1, here's 2, here's 3, here's 4, and here's 5, right? So they want you to show this picture. Now they're saying there are 8 people. Well, basically, all you have to do is you could pick another color or make a different shape, and it wants you to see how many people got on. So I have 5. I'm going to count on. 6, 7, 8. So I see that I added 3 blue circles when I counted on. So I did 5 plus unknown equals 8. Okay. 5 plus unknown equals 8. Well, I saw that I added 3 different colored circles to represent the people that got on the subway stop. So I saw that 3 more people got on to the subway stop. So that's simple. You guys know how to solve these equations. So now we're just solving story problems with those equations. Okay, we're going to move on. So go ahead. And turn to, and I'll erase that, turn to page 46. Okay. Turn to page 46. So that's right here. So we're looking at this problem right here. Number 1. You have 3 oranges. You buy some more. Now you have 6. How many oranges did you buy? So first I would say is I'd like you to write your equation. So you have 3, right? You buy some more. And now you have 6. Let's look here. You have 6, right? As you can see in your workbook on page 46, you have 6. Now, what it wants you to do is it wants you to use that handy little chart that you learned with Mrs. Salaki last week to put in the ones and count on till you get to 6. So I have 1, 2, 3, 4, 5, 6. So how many circles did I draw for the oranges that I bought? That's right. I drew 3. So 3 plus 3 equals 6. Simple as that. Let's keep doing some more practice. Okay. Number 2 on page 47. Okay. 5 kids are in a pool. Some more jump in. Now there are 7 kids. How many kids jumped in the pool? Okay, so again, we're going to write our equation. 5 kids are in the pool. Right? They show that here. 1, 2, 3, 4, 5. Some more jump in the pool, but we don't know how many more, right? Now, There are 7 kids in the pool total. How many kids jumped in the pool? Same thing. Put 5 in your head. Count on. 6, 7. If you need to, you can always put the numbers over this till you get to 7. So you could do 1, 2, 3, 4, 5, 6, and 7. Then you look at how many you drew in that second box, and I drew 2. So 5 plus 2 equals 7. Okay, let's do one more together. Okay, so number 3 says, you can hop 6 times. You hop some more times. You hop 10 times in all. How many more times did you hop? Now, this one shows that you hop 6, but it only gave you the number. So you hop 6, you hop some more, but we don't know how many more, and you hop 10 times in all. That's your sum. So it's 6 plus unknown equals 10. But this doesn't have this picture. So I suggest to you, strongly suggest, which means I'd like to see a picture or I'd like to see an open number line. So for this one, I'm going to go ahead and I'm going to draw the picture below it, and then I'll write the number in here. So I see this is 1, 2, 3, 4, 5, 6. That's how many times I hopped, right? Now I want to count on till I get to the number 10. So 6, 7, 8, 9, 10. Now looking at my red circles, how many more times did I hop? 4. So I'm going to write 4 here, or you could have drawn the 4 circles in here. So you could have also done this. You could have also done this piece. You could have done 1, 2, 3, 4. But you could have done 6, 7, 8, 9, 10. And seeing that you drew 4 circles in this box, this is how many that was missing, and this is how many more times you jumped. Okay? Now, I'm going to go ahead and I'm going to show you your seesaw activity just so that you have a better understanding of what to do. But if you need to, come back and watch this lesson and go over that practice together. Okie dokie. Let me find it. I apologize. I don't mean to make you wait. Okay. Found it. Okay. So this is your seesaw activity. So I gave you an example of how to solve it. I gave you the picture in the chart that you learned with Mrs. Lockie, as well as how to solve it with an open number line, okay? You are working on this on pages 48 through 50, okay? So the example is on page 48, and then your work is on page 49 and 50, okay? So you're looking at this example here, and you're going to solve these very similarly to how we did it together, okay? So this is page 49, and this is page 50, okay? So same thing that we've been doing, okay? So nothing has changed. I want to see that equation. I want to see that spot for your unknown number, the strategy, whether it's in that chart with a picture or you do an open number line. If you want to, do an open number line to check your work. It's great practice. And I want to make sure that you show me the answer where you found that answer. The reason teachers ask students to do all of these steps is so that we know what you're thinking inside your big old smart brain. Because guess what? Teachers cannot read minds. They're not Professor X. So they cannot read your mind. So you have to show us your work and show us your thinking. So that's the important piece. If you need to, come back and rewatch this lesson. If not, have a great day, and I'll see you next time. Thanks, boys and girls.